What is creatine? It's the most researched supplement in history, and it's also the most lied about. Today, we start with the facts. If you've spent any time around gyms, health podcasts, or wellness communities, you've almost certainly heard the word creatine. It's one of the most researched supplements in the world and also one of the most misunderstood. In this 4-part series, we're going to break down creatine completely, what it actually is, how it works inside your body, and whether it's safe. Plus, who should take it and how to use it properly. So let's start at the beginning. What is creatine? Creatine is a naturally occurring compound. Your body makes it primarily in the liver, kidneys, and pancreas, and you also get it from food, particularly meat and fish. Chemically, creatine is derived from 3 amino acids: arginine, glycine, and methionine. It's not a hormone, a steroid, or a stimulant. It's a naturally produced molecule that your body has evolved to use as a rapid energy source. Once creatine is made or consumed, about 95% of it is stored in your skeletal muscles. The remaining 5% is found in your brain, liver, and kidneys. Your body holds somewhere between 60 to 80 grams of creatine in total at any given time, depending on your body size and diet. Importantly, your muscles can hold more creatine than they typically contain, and that's the foundation for why creatine supplementation works. You can raise your muscle creatine stores above their natural baseline. To understand why creatine matters, you need a basic understanding of how your muscles produce energy. Your muscles run on a molecule called ATP, which stands for adenosine triphosphate. When a muscle fiber contracts, it uses ATP as its fuel. But here's the issue. Your muscles only store a tiny amount of ATP at any one time. Under intense effort, like sprinting, heavy lifting, or explosive movement, that ATP is used up within just a few seconds. And this is where creatine steps in. Creatine in your muscles exists primarily as phosphocreatine. And when ATP runs out, phosphocreatine donates its phosphate group to rapidly regenerate ATP. This process is almost instantaneous, which is why it's so valuable for high-intensity, short-duration activities. Think of it this way. ATP is like the cash in your wallet. Phosphocreatine is like a cash machine right next to you. The moment your wallet runs dry, you can refill it almost instantly. After roughly 8 to 10 seconds of maximum effort, your phosphocreatine stores are largely depleted. Your muscles then have to switch to slower energy systems like glycolysis and eventually aerobic respiration. By supplementing with creatine, you increase the amount of phosphocreatine available. That means that more ATP can be regenerated more quickly, allowing you to sustain high-intensity effort slightly longer or recover between bouts of effort more rapidly. So where does creatine come from naturally? Your body synthesizes roughly 1 to 2 grams of creatine per day from amino acids. Diet accounts for a similar amount for people that eat meat. Red meat and fish are the richest dietary sources. A pound of raw beef or salmon contains roughly 1 to 2 grams of creatine. And people who eat little to no meat, like vegetarians and vegans, tend to have significantly lower muscle creatine stores as a result. This is one of the reasons creatine supplementation has a more pronounced effect in people who don't eat animal products. Their baseline is lower, so there's more room to fill. And cooking reduces creatine content in food. Much of the creatine in meat degrades during heating, which is another reason dietary intake alone often falls short of saturating muscle stores. And it's important to know what creatine is not. Because it's strongly associated with muscle and performance, it gets lumped in with a lot of things it simply isn't. It's not an anabolic steroid, it doesn't manipulate hormone levels, and it doesn't mimic testosterone. And it isn't banned from any major sporting organization. The World Anti-Doping Agency does not prohibit creatine. Creatine is not a protein supplement. It doesn't directly contribute to muscle protein synthesis in a way that protein powders do. Its primary mechanism is energy related. It's not a stimulant, it won't increase your heart rate, it won't give you a buzz, or affect your central nervous system the way caffeine does. And the research is really strong. Creatine monohydrate is the most studied form of creatine and arguably one of the most studied supplements in the history of sports science. There are over 700 peer-reviewed studies examining its safety and efficacy. The research consistently shows that creatine supplementation increases intramuscular phosphocreatine stores. This improves performance in high-intensity, short-duration exercise, supports resistance training adaptations, and is safe for healthy individuals across a wide range of ages. And more recently, research has expanded beyond athletic performance into areas like cognitive function, neurological health, and aging, all of which we'll explore later in this video series. The breadth and depth of creatine's evidence base is genuinely unusual in the supplement space. Most supplements have a handful of studies, many of them industry-funded or poorly controlled. Creatine has been tested in elite athletes, older adults, children with medical conditions, and healthy non-exercising populations. In the next video, we'll go deeper into the performance benefits, what the science actually says about strength, power, endurance, cognition, and healthy aging.